Assalamu alaikum everybody, welcome to the second video of the first unit in IGCSE types and components of a computer system. We are going to resume where we stopped the last time, and we're going to start with analog and digital data. Everybody knows what analog is and everybody knows what digital means, but we need formal definitions or words from the books or definitions from the books that we can write on an actual IGCSE ICT exam. So computers can only understand data which is in binary format, which is base 2 number system where only values 0 and 1 can be used. This is often referred to as digital data because it can only have discrete discontinuous values. However, data in real world is actually analog in nature. Analog data is physical data that changes smoothly from one value to the next and not in discrete steps as with digital data. One example of an analog data is the radio signals, or maybe even the Wi-Fi signal. You know, it's analog, it has like waves like these, but the digital ones, it's either 0 or 1. Yeah, okay. In the above figure or the graph, on the left it shows analog. That one is the analog. An infinite number of values can exist between 1 to 6, for example. Well, the message is 1 to 6, so it's saying an infinite number of values can exist between 1 to 6. Like, for example, you can have 2.5, 4.652, and so on, right? Because the curve is smooth in shape. The graph on the right shows digital data. Notice only the exact values of 1, 2, 3, and so on. I don't know why he's giving an example of 6, but in digital signals you either have 0 or 1. You either have on or off. Yeah, okay. If analog data is being sent to a computer, it must first be converted into digital. Okay, if this is received by a computer, the computer has to transfer it into a digital. This is done by a hardware known as analog to digital converter, or ADC. Guys, I'm teaching you from the Hodder book. Okay, this may not be there in the Cambridge book, but it's good to know about it. Yeah, if the computer is controlling a device such as a motor, even a water motor, الدينامو بتاع الموتور في البيت, then the digital output from the computer needs to be converted into analog form. So if I'm controlling the motor from my computer, I'm going to be sending or generating digital data, but when it gets out of my computer, it has to be converted into analog form. This is done by a digital to analog converter. So we have two types: ADC, analog to digital converter, and DAC, digital to analog. Now moving on to main components of a computer system, we're going back to that. Okay, as already mentioned above, like earlier in the first video, a typical computer system is made up of hardware and software. We all know that. And the example of a computer system consists of input devices and output devices. And the last one is secondary storage. Okay, so input devices, output devices, and storage devices. These will be discussed in more details later in the second chapter, but here is an example of input devices, output devices, and secondary input devices: keyboard, mouse, camera, microphone, sensors, and scanners. All the devices that we use to give computer information or input information into the computer. Output devices: monitor, printer, speakers, projector, plotter. Guys, plotter is just like a printer, but it's just like really big. Okay, so any device that the computer uses to give us information. Now I'm going to take a second to Google plotter. You'll find out that it's just like a printer, but we are not allowed to say printer. Plotter images. So this is a plotter which like we use to print out billboard ads, maps. You see, I think they're trying to print out the map of the world. Here is an ad, another ad, a logo. It has a different technique of printing. It's not like laser it actually uses a pen. Anyways, so going back, the third kind of component is storage, secondary storage devices such as hard disk drive, solid state drive, or pen drive. Don't be fooled, pen drive is nothing but our flash drive. It's also called pen drive. Now, internal hardware devices were shown in the figure 1.2. Remember the hardware Let me get back to it really quick. These are the internal hardware devices: motherboard, RAM, ROM, sound card, hard disk drive, solid state drive, and graphics card. Yeah. Okay. And we've already discussed each and every one of them: the CPU, the internal hard disk drive or solid state drive, the RAM, the ROM. Guys, remember the annoying term that they've been saying over and over? This is basically a computer system. Okay, a computer system. It's a computer, but it has components. That's why we say computer system. The components are computer, monitor, printer, keyboard, mouse, and this tower here contains microprocessor, the internal memory, and storage devices. Yeah, internal memory could be the RAM and the ROM. Yeah. Okay. Now we've already discussed the CPU in the previous video. The RAM, which is a temporary random access memory, it stores the data temporarily, and it's called volatile. Volatile, there it is. It's referred to as volatile or temporary memory. The ROM is a read-only memory, and it like everything stored in there is permanent, cannot be edited or erased, and it's referred to as non-volatile memory. Okay, so let's read a little bit about the input and output system. Why? Because it's stored in the ROM. Okay, so it is worth noting that ROM also contains some coding known as boot file. Guys, boot in computers, it means to start the computer. When you start the computer, you would go through the BIOS first to test your input and output devices, and then the computer hardware gives control to the operating system. It doesn't directly go to the Windows or Mac or whatever operating system that you have there. Okay, it does booting first. This code tells the computer what to do when it first starts up. So the BIOS is testing your input and output hardware that's connected to the computer. If everything is fine, then it will move on to the operating system. Yeah. It's often referred to as BIOS. As a computer engineer or an IT person, this term is like ABC to you: basic input and output, or output system. Basic input output system. Okay, so it's explaining what I was saying over here. When a computer is turned on, the BIOS carries out a hardware check to find out if all the devices are present and whether they are functional. So first of all, it checks whether you have the hardware required to run the computer, like the mouse, the keyboard, the RAM, the hard disk drive, and all of that, the necessary hardware. And then check if they are actually working and nothing is wrong with them. Then it loads the operating system into the RAM. Yeah, that's the function of the BIOS. The BIOS stores the date, time, system configuration in a non-volatile chip called CMOS, complementary metal oxide semiconductor. And that's really interesting. This is usually battery powered. Even if you turn off the computer, it would still working with a battery. Okay, so here he created a table for RAM and ROM: temporary, permanent, volatile, non-volatile, can be written to and read from. This is a read-only memory, cannot be edited or altered. Used to store data, files, programs, part of an operating system currently in use. All the programs that are currently in use, but this one used to store basic input and output system and other data needed to start up or boot. Remember, boot means startup. It can be increased in size to improve operational speed of a computer. If you're a gamer, you can actually give your computer to maintenance and ask them to install more RAMs into that, but this one cannot. Input and output devices, we've discussed that, and I think we don't need to read more about that. An input device is any hardware device that allows a user to enter data or instructions into a computer. An output device is any hardware device that takes the output data from a computer and puts it into a human readable format or uses it to control another devices. Well, we don't need to get in depth and in details about this. Okay, backing storages. The main memories in a computer are RAM and ROM, but this is not backing storages. RAM and ROM are memory that we need for the computer to work. We don't store anything on them. Okay. Backing data, however, the permanently stored large amounts of data, it is necessary to use backing storage. This normally takes the form of the internal hard disk drive or solid state drive. So we need a hard disk drive or a solid state drive to save our files. Like if you have a cell phone, you use your phone memory, right? On a computer, we use hard disk drive or solid state drive. Okay, we also have the RAM and ROM. We also have a CD-ROM, but they haven't discussed this here. Okay. So over here he's having a table to compare internal memory and backing storages. RAM contents are lost when the computer is powered down. ROM contents are readable only. Backing storage devices hold their contents permanently even when the computer is powered down. We know that. Okay, you only have to delete them. Like if you need to delete your photos in order to lose them, right? They are there even if you switch off your phone or your computer, right? The RAM and ROM are much smaller memories than backing storages. That's true. Your hard disk drive can go up to 1 terabyte, but the RAM can be like 8 GB or 16 GB only. Okay. The operating system, we've studied that earlier in system software, if you can remember. System software, operating system, right here. It's a software running in the background of a computer system. It manages many of the basic functions. Without the OS, most computers would be very user unfriendly. Speaking about user unfriendly, we have several user interfaces that we need to learn that makes the computer user friendly. Well, one of them is not user friendly at all, which is the first one. Okay. Operating systems offer various types of user interface. We will consider 4 different types. The first one is command line interface, CLU, which is like this guy over here. Let me open it. So Windows, before it was graphical user interface, it was a command line interface. Basically, you have this and you need to type commands in order to operate your computer, right? So for example, if I want to get into this directory, I hope I get it, dir logs enter. Okay, so I haven't cd logs. See, it's very annoying. So now I just opened a folder called logs. I needed to write comments in order to do that. This kind of interface is called command line interface. We still have it because sometimes we need it for network issues and things like that. Like for example, if I want to know my IP address, I'll write ipconfig and press enter, and it gives me my IP address information right here. So sometimes as an IT person, you might need a command line interface. The next user interface is graphical user interface, which is just like this one. It has icons, start menus, windows like this one. This is a window and I can open multiple windows. Here is another window and I can move from one window to the other very easily. This is called graphical user interface. Now the next one is dialogue based user interface. Dialogue based user interface is like Alexa, where you need to use voice commands to interact with your operating system. Yeah, so it takes voice commands to accept instructions or process instructions. Now the last one is gesture based user interface. Gesture based user interface. This is like Xbox, where you use your hand to control the computer. You use your hand, you use maybe your face expressions, maybe you use your entire body, like the games where you have to stand and copy the dance, dance, everybody can dance or something. There was a game like that where you have to dance exactly like the avatar inside the screen, and then it will give you a score based on that. It actually reads your entire body movement. This is called gesture-based user interface. Moving on. So we've discussed all the user interfaces. Here it's going to go in depth in the advantages and disadvantages of each and every user interface. Okay, so let's just read this very quickly. The advantages of a CLI or command line interface is the user is in direct communication with the computer. The user is not restricted to a number of predetermined options. It is possible to alter computer configuration settings, like this one right here. It's really easy to get into the computer settings. This is what they consider advantages of the CLI. If it's really advantageous, then why everybody is not using them? The disadvantages is that the user needs to learn a number of commands to carry out basic operations. Not a number of commands, so much commands, right? The next disadvantage is all commands need to be typed in, which takes time and can be error prone. Thank you. So you need to remember the commands, and even if you forgot like a tiny letter or a punctuation, your command will not work. So each command must be typed in using the correct format. This is what I was saying, spelling and so on. Okay, moving on to graphical user interface. The user does not need to learn any commands, which is an advantage. It is more user-friendly. Icons are used to represent applications. A pointing device such as a mouse is used to click on an icon to launch the application. This is simpler than typing in commands. Well, nowadays we have a touch screen as well, where you don't even have to move the mouse, right? Now the disadvantages is this type of interface uses up considerably more computer memory than the CLI interface. Well, all of this is stored on my hard disk drive. That's why it's taking up a lot of my memory, and this is a disadvantage. The user is limited to the icons provided on the screen. Needs a more complex operating system such as Windows to operate, which can be slower to execute commands. Alright, moving on to the next comparison, which is dialogue-based interface and gesture-based. Okay, dialogue-based, no need for the driver, well, we're assuming that we're driving a car here, to take their hands off the steering wheel. No need for the driver to take their hands off the steering wheel. In a home, very useful for people with disabilities, because many tasks can be carried out by the spoken words only, like if turn on the light, turn on the AC, and so on. Possible to use as a security feature, because voice recognition can be used to identify a person, like open the door. If it's not my voice, it's not gonna open, right? Disadvantages is still unreliable, with many commands not being recognized or needing to be repeated several times, especially if there is background noise. Like when you're trying to talk to Siri, and you sometimes you ask for one thing and then it gives you a different result. It's happened with me so many times. It can be quite complex to set up or get used to. User needs to know which commands can be used. Okay, now with the gesture-based interface, it replaces mechanical input devices. I don't need a mouse, I don't need a touch screen. No physical content required. From far away I can move my hands and control it. Very natural interface for a human operator. Like you move your hand to the left and you swipe to the left, the computer swipes to the left. No training needed to interface with the computer. Now the disadvantages of a gesture-based interface is possible for unintentional movement to be picked up, like even when I'm talking and suddenly I get excited and then accidentally I'm giving the computer instructions. Only works fairly near to the camera or sensor. I need to be in front of that sensor. May only accept a limited number of movement. For example, it may take several attempts to find out exactly what finger movements are recognized. Okay, so I will stop on this at this note. I'm going to stop the video. This would be the second video in types and components of a computer. In the next video, I'm going to discuss types of computers and emerging technologies. Till I see you in the next video, take care. Bye.